Well, good morning, all. I have my cell phone out because I just made my donation to the Goltz Fund, and it was very easy to do, and I encourage you to do it. The instructions will follow on. Okay, welcome. I'm Evan DeLucia. I'm the director of the Institute for Sustainability, Energy, and Environment at the University of Illinois, and I also serve as on the governing board of the Ecological Society of America as your vice president for finance. And so it's a great pleasure for me today to kick off this lecture. But before I introduce Diane Pataki, I'd like to say a few words about the New Phytologist Trust, which is hosting this event. I'm an editor for Plants, People, and Planet, the newest journal from New Phytologist Trust. Some of you may know the New Phytologist Trust. It's an independent, not-for-profit organization that promotes and nurtures plant sciences. You're probably most familiar with the journal New Phytologist, and now Plants, People, and Planet. As with the ESA journals, all the revenues generated by the hard work of the authors, reviewers, and editors for the journal is put back into the plant sciences community in the form of supporting symposia, workshops, grants, sponsorships of conferences and events, lectures like this one, awards for early career scientists, including awards at the Ecological Society of America in the Physiological Ecology section and the Biochemistry section. So, is this a clicker? There we go. So New Phytologist, the flagship journal of the Trust, nicely complements the ESA family of journals. New Phytologist offers rapid publication of high-quality original research in 4 areas of plant sciences: physiology and development, environment, interactions, and evolution, with articles in highly respected Tansley Reviews and Tansley Insights covering topics that range from intracellular processes in plant cells all the way up to global environmental change issues. New Phytologist also aims to provide lively forum for commentaries, viewpoints on emerging research areas, meeting reports. Many of our reports from the ESA section, from various sections in ESA, have been published there, and so forth. Oops. So now I'm happy to highlight the 3rd issue of our new journal. Plants, People, Planet was published in July. The 2nd issue contained an article by Tom Lovejoy, who presented in this particular forum in 2017. Plants, People, and Planet is an open access journal focusing on the interface between plant science and society. Its vision is to promote and celebrate outstanding plant-based research in its broadest sense and become a go-to journal for everything new, innovative, and exciting in plant sciences that's relevant to society and the daily lives of people. There are 6 main topics in the journal that are illustrated behind me. New Phytologist Trust is especially proud of its long and established relationship with the Ecological Society of America and is excited to support ESA through sponsorship of this plenary lecture. This event was established in 2015 to celebrate ESA's centennial year and will hope it continue for many years going forward. Previous speakers in this series have included Chris Field, Janine Cavender-Bars, Tom Lovejoy, and Dave Schimmel. So to learn more about the family of journals in New Phytologist Trust and the relationship between the Trust and the Ecological Society of America, I encourage you to visit booth 205, where Dr. Holly Slater will be manning the booth. She is the senior commissioning editor for New Phytologist. So now I'm very happy to introduce this morning Diane Pataki. Diane is a professor in the School of Biological Sciences at the University of Utah and also holds additional appointments at the University of Utah, including an adjunct appointment in the Department of City and Metropolitan Planning. She also serves as the Associate Dean for Research in the College of Science and Associate Director for the Center of Ecological Planning and Design. Diane joined the faculty at Utah in 2012. Before that, she was on the faculty at the University of Irvine. She received a BA in Environmental Science at Barnard College and MS and PhD degrees at the best university in the world, Duke University Nicholas School of Environment. Go Blue Devils. Diane's work has spanned the impacts of global change on ecosystems, the use of stable isotopes to study coupled human-natural processes related to urban CO2 emissions, and the impacts of urban vegetation on local climate, pollution, and hydrology. Her research is focused on improving understanding of the interactions between vegetation, the physical environment, urban planning, forestry, and design. Her lab utilizes methods from plant physiological ecology, ecosystem science, and bioclimatology to measure the impacts of urban landscapes on urban climate, pollution, atmospheric chemistry, and human thermal comfort and well-being. Diane has been honored via a fellow from the American Geophysical Union, and she serves as specialty editor for urban ecology at the journals Frontiers in Ecology and Environment, our journal of Frontiers, Ecology and Environment, and Frontiers in Sociology. She is also a member of the National Science Foundation Directorate for Biological Sciences Advisory Committee and the NSF Advisory Committee for Environmental Research and Education. She is also our incoming ESA Vice President for Science in 2019, although she has already taken up those responsibilities at this meeting. The title of Diane's talk today is The Ecology of Cultivated Landscapes, Theoretical, Methodological, and Ethical Concern. Please join me in welcoming Diane to today's lecture.
Thank you so much. I really appreciate that you all are here today. I really want to thank the New Phytologist Trust for inviting me and giving me this opportunity to speak. Their new journal, Plants, People, and Planet, is really exciting. It's exactly in my research area. And as soon as they put out a call for submissions, my group immediately started submitting papers because there really has been a shortage, I think, of journals that could address the interaction between humans, vegetation, and the environment. And that's what I'm going to talk about today. So here we are in Louisville. Louisville, did I say that correctly? I want to talk today about highly, highly cultivated landscapes, like the landscapes that you see here, where it's become increasingly of interest to ecologists to study cultivated ecosystems and cultivated organisms. And what I've done in the last few years at ESA is I like to come and bring a problem that is very difficult, something that's been vexing us, that really requires dialogue from the community to help solve. And that's what I want to do here today. I want to pose some ideas, some questions that don't yet have definitive answers, and I hope it can stimulate some discussion and get some feedback. So this room is very large. It's probably not the best venue for dialogue right in here, but over the coming week, I hope that people will come talk to me, and we can also think about continuing this discussion perhaps at next year's Ecological Society meeting. And I also want to acknowledge people who might be watching this online, because I'm really excited that the Society is now starting to put some talks online and giving people more access to the meeting. So I should define cultivated landscapes, and what I'm going to use today as a framework are landscapes in which people add and remove species. So these are agricultural landscapes, these are many urban landscapes, these are some rangelands and pasture lands, and depending on how you define these landscapes, these areas could constitute almost a third of the land surface on Earth. So cultivated landscapes, quite important globally. And we can also talk about cultivated organisms. And so in the last few years, people have cited these data quite frequently. And they are sobering data that show us that the animal biomass on Earth is now 97% people and cattle. And only 3% or less of animal biomass is wild. And that proportion is going to get even smaller over time. So we can also think about cultivated organisms as domesticated organisms, domesticated plants and animals. So the question for ecology for many years now has been, how should these kinds of organisms and these kinds of landscapes be incorporated and studied in ecology? And so in 2017, there were actually 2 papers in Philosophy of Science that cited our own definition of ecology from ESA, this definition that you're all familiar with, and posed the question, do humans and cultivated organisms fall underneath this definition? There's really nothing in this definition that excludes cultivation. But if one looks at the literature in ecology, it's unclear the extent to which cultivation is part of ecology or not part of ecology. So this paper by Mark Sagoff, now Mark Sagoff's getting some airtime here today because Katie Suding also quoted him in her excellent talk earlier this morning. I am quoting a different paper where Sagoff did an analysis, looked at the Journal of Animal Ecology, which is a journal of the British Ecological Society, over its history and tried to find examples of people studying, in this case, cultivated animals, and finding very, very little evidence that people were studying cultivated animals in the same way that they were studying non-cultivated animals. So he asked, in this case, what entitles ecologists to exclude cultivated plants and animals from the domain of their science? And after a philosophical analysis, he came to the conclusion that nothing entitles us to do this. And we don't ignore cultivation. We study lots of different aspects of agroecology and urban ecology, and we have sections of the Ecological Society dedicated to agroecology and urban ecology. And this is actually a photograph from my lab. This is a picture of Amy Townsend Small. She's now a professor at the University of Cincinnati, and she's measuring methane emissions from cattle. So, we do these things. But in this case, we're basically treating cattle as a disturbance, an anthropogenic source of methane to the atmosphere. And this is commonly the way we treat cultivation in ecology. There's also a lot of work on predation and, cats. I mean, if you Google cats and predation, you're going to get like hundreds of these pictures of cats eating birds and other taxa. And this is a paper from Nature quantifying bird predation by cats and mammal predation by cats, which is a very ecological thing to do. But even in sort of the public discourse and the media, there is this notion that domesticated animals harm the environment or disturb the environment. And so the tagline for this paper, which was published in Nature, and this image was published in Nature, was, "Cats are enemy number one." And I'm not even a cat person, but I thought that was a little problematic. I mean, there are lots of predators in ecosystems. There's lots of species that use predation as a mechanism of getting food and energy, but we single out domesticated species as something that is different, something that's outside the ecosystem. And so to explain this, there was another paper that year in Philosophy of Ecology that went through the literature on treating humans as a disturbance to ecosystems. And this was a paper by Andrew Inkpen, and he described the way we frame disturbance in terms of our language, in the terms of the places that we study, which are usually not cultivated landscapes, in our experimental practice, and even in theory, and in sort of the models that we choose to explain natural phenomenon. And there are other ways to frame doing studies of cultivated organisms, and I found this paper, which is actually in the Journal of Animal Ecology, the same journal, an older paper from 1944. This is actually one of the earlier uses of the term urban ecology, sort of outside the Chicago school. So in the true use of the term urban ecology that we apply today, where the author just counted domestic cats in cities in the UK. Didn't really comment on whether these cats were a disturbance, whether they were part of the ecosystem or weren't part of the ecosystem, but just counted them and talked about some of the reasons why different cities had different numbers of cats. So the question is this sort of the approach that we should go back to, or should we treat domesticated animals as an issue that that will threaten ecosystem services and well-being in the future given massive environmental change. Like, how should we deal with these cultivated landscapes and cultivated organisms in ecology? So, for an outline, in terms of the question, does ecology include the cultivated? I mean, those of us who study urban and agricultural ecosystems are trying to include the cultivated in ecology. And I would say that as of now, the incorporation of cultivated into ecology is sort of incomplete. It's uncertain, I think, what our conceptual framework is when we study these systems. When we do study these systems, I would like to elaborate on some different models, some different conceptual frameworks that people are using now very actively to understand these systems. And then I want to go into the ethical dimensions of cultivation, because I think that the reason why cultivation is at this boundary between what is inside and outside ecology is in part because people have ethical concerns about the impacts of cultivation on society, on natural ecosystems, and instead of sort of avoiding that issue, I think we can just take that issue head on and have a conversation about ethics, and that might help us guide our choice of models going forward. Okay, so this is the outline. Now, the first way we could approach cultivated ecosystems is simply to treat them in exactly the same way as non-cultivated ecosystems. So this is actually the approach advocated by Sagoff in his paper on philosophy of science. And he points out that ecology is virtually the only discipline of science that distinguishes domesticated organisms from non-domesticated organisms. That other disciplines in biology, like cytology, physiology, and genetics, really don't distinguish whether you're studying a cow or whether you're studying a wild species. They just measure cytology and physiology and genetics of different organisms and don't really distinguish the origin of those organisms. And that could be one way that we could move forward. But having tried this method of bringing cultivated organisms into ecology, I actually don't think that that method works particularly well. So if you take the example of community assembly and community ecology, trying to understand why a certain group of organisms exist in an ecosystem. How do these organisms get there? Why do we have different levels of biodiversity and different types of community composition in different ecosystems? We have models, conceptual models, to explain community assembly. Usually, there are a series of filters by which the species pool gets smaller due to processes like dispersal, due to abiotic factors in the environment. Species can tolerate certain conditions or not tolerate certain conditions. And then there are competitive interactions among species, biotic interactions, that determine how a set of organisms came to be within a certain ecosystem. But if you try and do this for cultivated organisms, it really doesn't work particularly well. So if you take a highly cultivated landscape, and a lot of the examples that I'm going to use today are in urban cultivated gardens, because it's largely what I study, you can't explain the composition of a cultivated garden in this way, because these species did not arrive by any of these mechanisms. And in fact, a lot of cultivars in the urban horticultural environment are sterile. The only way to explain how they got there is by human agency. So there's something different about these taxa that we need to account for in certain areas of ecology. So for this reason, I think rightly so, ecologists do not treat cultivated and non-cultivated organisms in the same way. And this is an alternative community assembly framework from Will Pierce, who is now at Utah State University, where he has attempted to distinguish between a cultivated pool of organisms and what he calls the spontaneous pool of organisms, the organisms that regenerated without being planted. They naturally regenerated. So this is an argument for distinguishing cultivated organisms. There's also a lot of explanatory power in understanding how species became domesticated and what happened to those species in the process of domestication. So in ecology, we want to understand the functional traits of organisms and the structure and function of organisms and how those processes come together and interact with each other in an ecological sense. And it turns out that there are predictable traits, suites of traits in domesticated organisms, which collectively fall under a domestication syndrome, which has been extensively studied in evolutionary biology. And this is another case where evolutionary biology and ecology, if they come together, there's a lot more we can learn about domesticated organisms and domesticated ecosystem processes. So in animals, there's quite a good understanding in evolutionary biology and developmental biology of why domesticated animals exhibit certain traits. In plants, as is usually the case with plants, the situation is more complex, but this is a very interesting paper by Ruben Mia and a group in Europe looking at plant functional traits and the extent to which domestication syndrome is present in crop plants. And so on the y-axis here is leaf nitrogen, and on the x-axis is specific leaf area. So this is a classic leaf economics analysis showing that, it shows a few things. Crop plants tend to be fast. They have rapid growth and they demand a lot of resources. And the question is, were those traits bred into crop plants? Did the domestication process result in those traits? And the answer is maybe not, because the wild progenitors of those crop cultivars are also exhibiting the same leaf functional traits, also fast-growing species that demand a lot of nitrogen. And there's some really interesting taxa-specific variation here, particularly in Poaceae, which shows that even within the family of Poaceae, that the progenitors of the species that became our crops actually have very high leaf nitrogen relative to other species within the same family. So this is ecology, and it's an ecology that's really, I think, at an early stage of understanding how domestication has shaped ecological processes that we measure. And so there's been way less work on ornamental plants. A lot of this work has been in crops, and I'm fascinated by ornamentals, and especially by flowers. So this is an older paper. It's from 1993 in a journal called Leonardo, and it's a journal about incorporating science into art. So this is not a journal I would normally read. But I came across this paper, and it talks about this ornamental aspect of domestication as a process of convergent evolution. Because all of these flowers, these are specific cultivars where every flower is in a different family. Humans really like to breed double flowers for reasons that I would say we don't fully understand. We really like double flowers, and they are found in nature, but they're kind of rare. And so the only thing that can explain this convergence is human agency. And understanding that human agency can help us understand a lot about the structure and function of these ornamental landscapes. And I want to acknowledge the author of this paper, who is an artist, and that's going to become important later in this talk. I want to come back to how art can help us understand the process of domestication and the process of cultivation. And he actually works with hybridizing flowers as a form of fine art, which I think is very, very interesting. But basically, I don't agree that a useful path forward is to always treat cultivated and non-cultivated organisms in exactly the same way. I think we want to know that an organism is a cultivar, and we want to know how it became cultivated, and we want to come up with some general theories and some general explanations for why different cultivated organisms exhibit certain functional traits in ecological processes. And most ecologists, I think, would agree with that. And so now I want to move on to a very common theoretical framework that's been used in urban ecology and agroecology, which is frameworks that you could call socio-ecological or coupled human-natural frameworks. And since that term was kind of popularized by a program at NSF, what I'm showing here are the conceptual frameworks for the 2 phases of NSF's program on coupled human-natural systems. But there's lots of diagrams like this. There's lots of ways to frame what's basically a dualistic framework. It's a binary framework. And it says that there is a system one can call natural or biological. And then there's a system that one can call human or social. And there are some processes that link these 2 things. But to use this framework, you have to be able to distinguish between these 2 aspects of the system of study, right? And this is a very useful framework for a number of applications, but it gets really tricky when you're studying cultivars. I don't know if anyone has tried to do this, but I'm going to use an example of Kentucky bluegrass. And I actually picked this example before I remembered that I was going to be giving this talk in Kentucky, but now it's particularly appropriate. So Poa pratensis is a grass that is not probably native to Kentucky, but honestly, we don't know the native range of Kentucky bluegrass. So this map shows the range as being located throughout Eurasia. But you know, it's been cultivated in Europe for so long that its natural range there is unknown. And it came to the New World, to North America really early, at least in the 1600s. Some botanists think it may actually have been native to some parts of North America. We just don't know, because humans have been cultivating this thing for a long, long time. Now, if you look at the herbarium sample here of Poa, you feel like, okay, that's a natural system. That's a plant. It belongs in the natural box, right? But then there's this stuff. So, you know, Poa, there's over 200 cultivars of Poa pratensis. It's a very, very popular turf grass. The reason I actually picked it is because it's the most common turf grass where I live in Salt Lake City. So we end up studying it quite a bit. And you can go to Home Depot and buy all of these different versions of it, and they are strictly human created. They are genetically controlled. Some of these cultivars have traits rarely found in nature, like they're resistant to herbicide application and so forth. So now, do these cultivars belong in the natural box or do they belong in the human box? I mean, I just don't know where they go. And so it turns out this is a really old problem because even Aldo Leopold had some writings about Kentucky bluegrass. It's discussed, actually, in the Land Ethic, where Leopold writes, the cane lands, when subjected to the particular mix of forces represented by the cow, plow, fire, and axe of the pioneer, became bluegrass. That is, Leopold recognized that it was through the disturbance, it was through the actions of pioneers that this grass invaded these areas of the United States. And then he writes, what if the plant succession inherent in this dark and bloody ground had given us some worthless sedge or shrub or weed? That is, bluegrass it's attractive, it's green and lush, and it made the plains look attractive for settlement. And if some other plant had invaded, something kind of harsh and ugly like tamarisk, I can't stand tamarisk, are you guys familiar with this one? Or an artichoke thistle, something that does not look like it would promote human settlement, then the whole history of the settlement of the frontier would have been different. He asks, would Boone and Kenton have held out? Would there have been any overflow into Ohio, Indiana, Illinois, and Missouri? Any Louisiana Purchase? Any transcontinental union of new states? Any civil war? And so, you know, is the Civil War dependent on this little grass invading the plains? This observation that the history of the United States was intimately tied to this plant is part of the basis for the land ethic and Leopold's observation that we are intimately connected with ecosystems. And I'm not sure that Leopold would separate out a human system and a natural system in this case. Okay, So we can measure things on Kentucky bluegrass. It's a plant, and we can take measurements. So this is a graph that's just showing the evapotranspiration of lots of different urban ground covers. And sunlit Kentucky bluegrass is the upper middle panel, the light green. So Kentucky bluegrass cultivars have this extraordinarily high rate of evapotranspiration, more than any of these other ground covers that we've measured. And Rose Smith in my lab will be presenting more of these data on Thursday at the physiology session, I believe. But, you know, we would like to know. This is an ecological question. Why do we see certain flux rates in certain species? So why is turfgrass ET evapotranspiration so high? And we ask the same question with other species in the urban environment. These are data on the transpiration of urban trees of lots of different species. And there's a ton of variation of the physiological and gas exchange rates of urban species. And it's a very ecological question to ask why that is. So one might say, well, perhaps we see higher flux rates in species that are non-native. But it turns out in our examples, we don't really find that. We don't find categorically different rates of gas exchange in native and non-native species. And we could say, well, maybe these differences in traits are explained by the native habitat, the environmental conditions in the habitat where this species came from, because it's adapted to certain conditions. And we do see some of that. So for example, these data are from Los Angeles, and trees that are native to Australia have a much lower transpiration rate in Los Angeles than other species. So it may have something to do with adaptations to conditions, native conditions. But I also want to ask, how much of this variation is explained by the process of domestication, that is, by artificial selection itself? And I can't answer that now because there's been very little study of this, but Darwin distinguished between two kinds of artificial selection. What he called methodical selection, which was intentional hybridization of species, and then something that he called unconscious selection, which is when people inadvertently directed evolution by selecting certain organisms or certain seeds. And I'm not sure that we understand the consequences of either of those processes on ecological traits. And further, we would ask in ecology, I think, if artificial selection is important and it does drive ecological processes, then what drives artificial selection? What are the processes that led to domestication and certain types of domestication? And I don't know that coupled human-natural system frameworks are going to get us there because it's difficult. It's just difficult to place a cultivar in a human versus a natural system. And so another framework that people have used recently, which is quite useful, is the ecosystem services framework. And that means using the concept of ecosystem services to try and explain something about the process of domestication and its consequences. So this diagram, which is going to be very tiny in the back, but it's a common diagram. It's the Pulse Press framework from the Long-Term Ecological Research Network. And it is a social and biophysical model linked together with ecosystem services as the interface between the social and the ecological part of the system. That is, we could pose a hypothesis that ecosystem services are an interaction between people and between nature that we can understand and study. So I like this model more, actually, than I like coupled human-natural system models because it's interactive, because it gives us a way to characterize the interface between people and cultivated landscapes. And it actually has a hypothesis, which is that we have a particular set of interactions with nature that, in terms of extracting services from nature. And it's true that even ornamental cultivars provide ecosystem services. For crops, it's straightforward to understand ecosystem services if crops are provisioning goods and food. For ornamentals, it's a little bit more difficult, but this is a graph that's showing humidity and temperature in an urban environment as a function of the percent turf grass cover in parks in Salt Lake City. This is the work of my PhD student, Carolina Gomez Navarro. And it's true that turf grass makes things cooler, and it makes things more humid in a desert environment. This is a very, very important service. So from this perspective, we certainly can quantify ecosystem services of these cultivated landscapes. But I don't know that this explains a lot about our relationship with lawns. It's true that lawns make things cooler, but does this really explain why people spend so much time cultivating lawns? It may explain part of it, but there are other factors at play in the evolution of domesticated landscapes. And I'm going to go back to this paper by George Gessert, where he talks about the fact that sometimes we just don't know why we do things with respect to domestication. And here is an example of bearded irises. And there is a bearded iris on one side here, and then there's a ruffled cultivar of iris on the other side. And it's an award-winning iris. And so this paper talks about the fact that awards at horticultural shows drive a lot of aesthetic preferences for flowers. And when it becomes fashionable to breed ruffled flowers, we start to see a lot of convergence of ruffled petals as a trait. And he brings back this notion of unconscious selection, kind of in a different way than Darwin, I think, intended it, to say that we do these things for complex reasons. They become social norms, and you can't always explain these in terms of very quantifiable ecosystem services. And in fact, if that's true, if plants are operating on us in some unconscious way, then maybe we'd expect that in some places, plants would prey upon us as the victim. Plants would manipulate us. In other words, this relationship could be characterized in biology as a mutualism. So this is a process that benefits multiple species. Do we get services from lawns? Yes. But lawns get services from us. Extensive services. So this is a very commonly cited data set from Christina Malacy from 2005 showing the spatial extent of turf grass in the United States. Not just for ornamental purposes, but sod farms are needed to support all of the trade in turf grass. And these plants have found a way to disperse themselves across the landscape, right? Not through dispersal mechanisms that we normally think about, but by persuading us to cultivate them and to pour enormous resources into caring for lawns, enormous amounts of water and nitrogen and money and time. And if you flip this around and think about this relationship from the perspective of the plant, then we've been manipulated. We've been duped. And people are talking about that now. There's been lots of articles in the news recently about all the time and money and resources that we spend on lawns in particular. But this could be true perhaps of many, many different relationships between humans and domesticated species. By most definitions, these relationships could be thought of as mutualisms. I'm not sure ecosystem services captures that completely. So the final model here that I want to talk about is what I'm going to call embedded models of studying cultivated landscapes. And that encompasses a whole number of things. This photograph is from the ESA Earth Stewardship Initiative. So every year at ESA, there is an effort to work on a design project in the host city, and there will be one again here in Louisville later this week. And these are collaborative efforts between designers and ecologists to actually change spaces in the cities that host the meeting. This is what Alex Felsen calls designed experiments. There are also frameworks in ecological planning. I'll show you one of those in a moment. And lots of people now are talking about the co-production of knowledge between scientists and stakeholders and engaging in participatory research with communities. And in the area of cultivated landscapes, these often take the form of projects where ecologists are on design teams with professional practitioners, and are actually helping to make decisions about what gets cultivated, for example, in an urban environment. And these models are useful for many reasons, and one of the reasons they came about is because normally the process of getting scientific information to people that plan and design cultivated landscapes is really slow. So this is a process model showing how science and landscape design and planning work normally. And we all have a process. So familiar to us in ecology and science, we observe the environment, we make a hypothesis, we design experiments to test the hypothesis, and then our experiments produce this thing called knowledge. And many years later, like sometimes decades later, that knowledge is found somewhere by a planner or a designer. And it's slow, and the information can be misinterpreted. And so to improve this process for the goal of making designed places better places to live, people have tried aligning these processes together so that planners and designers and ecologists can work together on a team and shorten the time for information exchange. And this hopefully would make the output better. The final product of designing a landscape hopefully would use better scientific information. And so I collaborate on these teams. I think this process is extremely useful. But what we do as scientists when we play these roles is quite different than what we do when we're, say, translating our research into use by somebody else who's going to make a decision. In the context of a collaborative design team, everyone at the table is making decisions. So scientists not only are scientists, but they also become decision makers. They're not just informing decision makers or informing policy makers. They are decision makers. And to show you an example of what can happen in this context, here's a little piece of data, and I say little. This graph summarizes about 15 years of work in my lab trying to quantify the flux of water from landscapes in Los Angeles. So these are monthly estimates of the entire flux of evapotranspiration from all the landscapes in Los Angeles, scaling up a lot of measurements. And the black bars show the turf grass component of that ET. So turf grass uses a lot of water in LA. It constitutes a lot of the water flux of landscapes. And so, from this perspective, turf grass is causing a problem in terms of using scarce water resources. So, we didn't do this study for pure curiosity. We did this study in part because the information was needed in a social and environmental context. California is experiencing a massive drought, and we got funding from NSF to do a study of water sustainability and how to better manage local water in LA. So we gave that information to decision makers, and other people were giving information to decision makers, and lots of things were happening in the context of trying to respond to a severe drought in the region. And in response to that, policymakers decided to take action. And they started a program to incentivize the removal of turf grass, a monetary program. So if you agreed to remove your lawn, you got a rebate. And it was a very popular program. All the money, and it was something on the order of $350 million, was spent in a couple months. So people removed their lawns. What they put in place of lawns became rather controversial because people didn't have a lot of knowledge or a lot of resources for alternative designs for landscapes, and a lot of the landscaping that went in was very devoid of vegetation, and people weren't entirely happy with the outcome. But this system here, I guess, this ecosystem, this set of processes, involved the science. Science is not external to what's happening in this system. It's in it. It's part of it. And there's a theory, or I shouldn't use the word theory because it's not a theory in the sense that we use it in science, but there is an approach, a framework to study this kind of a system in a sort of a non-hierarchical way, where we don't assume a priori that one set of actors is driving other sets of actors. So actor network theory was popularized by philosopher Bruno Latour, and you may see this work recently with reference to the critical zone observatories, studying how scientists are approaching the critical zone. Actor network theory is a really good way to study a set of relationships like mutualisms, because it doesn't presuppose that humans drive what's going on in the ecosystem. You can study the ecosystem from the perspective of any actor, and an actor can be any organism that does things. It could be turfgrass, it could be non-humans. And it's also been used extensively to study how science plays a role in ecosystems. And this is a paper from Henrik Ernsten that studies how different green spaces in cities all over the world have evolved. And in particular, this group has looked at the High Line project in New York City, very, very famous park that reclaimed an abandoned railway in Manhattan. How did the High Line come to be? That's a very ecological question, actually, is to just take a look at this park and say, how did these organisms all assemble? Well, these organisms assembled in a way that's not easy to explain with a coupled human natural system framework or with ecosystem services, because it was a very complex set of relationships in which scientific information, and in this case art actually, played a role in influencing people's decisions about what to do. There was a famous set of photographs that was displayed that took pictures of weeds, of plants that were recolonizing the railway. It was basically pictures of plant succession. And they really motivated people to act and reimagine this space in a very creative way. So, okay, so I need to get to the last part of this talk. Now, I want to get right to the heart of the problem here, the reasons why ecologists are reluctant to study these cultivated systems. And if you do this thing, so you build a highline park, and that's a really large intervention in a space that was experiencing plant succession. And when they built the High Line, they took all those plants out and they started again. It was a completely designed landscape. So if scientists participate in this kind of activity, then there is the potential to do harm. So this is the ethical component of this piece. And I know that many people are worried about this. Why don't we like to study cultivated systems more extensively? Well, there's the potential to cause harm to other species. Cultivars have escaped and become invasive species. There's the potential to harm the communities, the people that live or depend on these systems. And then there's this notion of scientists acting as decision makers and this conflict between the value-free scientific ideal that sort of underlies what we do and the fact that scientists would be called upon to be non-objective. So I'm going to address these things directly. And I want to say that the potential for harm is real. So one negative consequence of the High Line was massive gentrification around the park project. The cost of living just skyrocketed around this park. And this is a very, very real issue and one that I'm personally sensitive to. I'm actually from a part of New York City that has become greatly gentrified in the last few years. People that I grew up with have been pushed out of neighborhoods because we've done things like created amenities like parks in cities. And so if we engage in these kinds of activities, there really are consequences. Okay, so the final part here will be about ethics, and here I want to acknowledge my collaborator, Carlos Santana, who is an environmental ethicist and philosopher at the University of Utah, and any errors that I'm about to make in characterizing ethics are entirely mine and not his. Okay, so back to the Code of Ethics for ESA. We've been talking quite a bit about the Code of Ethics for ESA in the last couple of days. But here I just want to point out two pieces of the Code of Ethics. The first one is basically a do no harm statute that says that ecologists will avoid or minimize adverse environmental effects of their activities. That is, our research should not cause harm to the systems in which we study. And I think in a cultivated landscape, it is very unclear what that harm is. And if we can't characterize what the harm is to cultivated systems, it's very hard to avoid it. So there's an issue there. And then we also have a statute that says that ecologists will engage meaningfully with the communities in which they practice. This is really the heart of the matter, I think, for me, working in cultivated systems. So I want to delve into this a little bit, and I'll use this particular framework, which you may have seen. So most universities, they will require that students take some kind of responsible conduct in research training, the RCR training, and some people think that training is too narrow because it only focuses on procedural ethics. So most of the ESA Code of Ethics is procedural. It focuses on things like avoiding plagiarism, not falsifying data, following regulations for human subjects research and IACUC and so forth. Some people want to make that framework a little broader. And so here I want to talk about intrinsic ethics and extrinsic ethics, which are separate, sometimes can be separated from procedural ethics. Intrinsic ethics are things like the choice of model, the choice of data, the actual practice of science that has an impact on the outcome. There's actually been a discussion about this on Ecology in the last week or so. That's been interesting. Extrinsic ethics are the impacts of what we do on society. And so traditionally in cultivated ecology, the choice of model, like which model of studying cultivated ecosystem are we going to use, would be an intrinsic ethics issue. Now, the issue of how to cultivate a landscape, what to plant, would be considered an extrinsic issue because it's something that society does with our data, and we're not making that choice ourselves. But in the embedded model of doing science with stakeholders, both of those things fall at the interface between extrinsic and intrinsic ethics. And this is really tricky. We don't have necessarily a current approach, I think, within ecology then for knowing how to deal with these choices. So one option here, and you don't need to read this, is to go to a different kind of a profession that has more of an ethics, a code of ethics in the public interest. For example, the American Planning Association has a whole set of ethics about how people should engage because they have a responsibility to the public. For example, we shall always be conscious of the rights of others. We shall have special concern for the long-range consequences of present actions. We shall pay attention to the interrelatedness of decisions. It's kind of a different approach than we take here. And it would be interesting to think about using something like this, but it also has something missing, which is that we're scientists and we have another mission, which is the pursuit of knowledge. And sometimes the pursuit of knowledge and the public interests, they actually can be at odds in the short term for certain communities. So that, for example, it's possible to do a scientific experiment that has a negative influence on communities. That's why we have to get institutional approval for human subjects research. So there's another profession that has to deal with exactly the same conflict, and that's the medical profession. So the American Medical Association states that physicians are also scientists. A physician shall continue to study, apply, and advance scientific knowledge. And yet a physician also has other duties and responsibilities to provide competent medical care, to respect the law, and also to seek changes in the law, which is interesting. If the law is contrary to the interests of patients, then there is a duty to try and change the law. That's different. A physician shall recognize a responsibility to participate in activities that contribute to the improvement of the community and the betterment of public health. So it's interesting to think about this. When my colleagues first raised the issue of looking to biomedical ethics as an example, I was not enthusiastic. I said, these are different issues. Human health is clear-cut. This was my impression at the time. And ecosystem health, that's a more nebulous concept. And my colleague said, well, you should read the literature on human health. It's not as clear-cut as you think. And it's true. It's actually not a clear definition of human health. What is human health? It has the same issues that we struggle with when we try and define ecosystem health. There's an objective component of both kinds of health. There are things we can measure. We can measure physiology, human physiology. We could measure ecosystem structure and function. But there's also there's many subjective components. Like if you have a disease, how is it going to impact your lifestyle? That's going to vary from person to person. Depends on who you are and your values and your physiology. And for environmental health as well, there's also the subjective component, ecosystem health. Depends in part on environmental values. So there's a lot of interesting parallels here. What maybe we would want in the end is to distill some basic principles, something analogous to the 4 basic principles used in American biomedical ethics. So those principles, which are derived from a volume by Beauchamp and Childress, are justice, and I think most ecologists are interested in justice. That's why we're worried about gentrification. There is non-maleficence, to do no harm. And we already have a statute on doing no harm in our code of ethics. And then the next 2 are a little tricky because there is further a principle of actually actively trying to do good, which is not a principle that we currently articulate. Furthermore, the principle of doing good can be at odds with the last principle of respect for autonomy. And it turns out that the autonomy of people and the principle of a professional coming in and doing good, they can be at odds too. So for example, this famous case from Case Study Ethics, the patient comes to a doctor and says, "I'm here because I need to have my arm amputated." And the surgeon said, "Okay, why do you need your arm amputated?" And the patient says, "It's the only way I can expiate my sins." The patient is autonomous, so in this case, do you respect the patient's wishes and amputate an arm when there's no medical cause? I think there's a parallel here with this problem that we struggle with a lot in urban ecology, which is that people don't want, sometimes, the kinds of green spaces that we think are good for them. Anybody who's worked on urban tree issues comes across communities that don't want trees. And there's 2 ways to approach this. You can say, well, if we teach people that trees are good, maybe they'll want them. It's a deficit model of environmental education. Or we could say we have to respect the autonomy of communities. So if they don't want trees, we won't plant them. But there's a middle ground. And the middle ground is something that people struggle with in medical ethics. So the purely beneficent model may violate autonomy, but people need options. They need information. You're not going to get a medical degree before you decide to get surgery. You're not going to become a PhD ecologist before you decide to plant a tree. You need a range of options, and there needs to be this balance between autonomy and beneficence. And then finally, the principles of informed consent probably can help us navigate some of the tricky issues, I think, in communicating these scientific uncertainties. Okay, so this is the final bit here. There's lots of models for medical ethics. I mean, this is just an initial. I just want to show you what this might look like. If we took a set of principles and we took the word patient and we substituted communities, because we deal with communities, not patients, and we took the word physician and we substituted ecologists, what would a set of principles look like? It would look like this. Both ecologists and community members must be free to make informed decisions and to act fully as moral agents when engaging in these embedded, cultivated ecology models. Ecologists have the greater responsibility because of the inherent inequality of information and power. Scientists have more power. Ecologists must be persons of personal moral integrity. That's language that makes me a little that's a high bar. That's a high bar. I definitely think twice about that one. I just take that seriously. And ecologists must respect and comprehend moral ambiguity, yet not abandon the search for what's right and good in each decision. So this is like weighty stuff right here. But, these are the kind of exercises, I think, that we need to talk about if we're going to engage in these types of collective models. Okay, I don't know if you noticed, but for the last few slides, the background changed. And instead of a sort of a backdrop of Kentucky, we now have a backdrop of Salt Lake City. So we're kind of looking forward to 2020 here, because we can keep talking about this at next year's meeting. And the summary here is that, does ecology include the cultivated? I don't think that we have fully done our job in integrating cultivated organisms into ecology, if that's what we want to do. I went over some existing models for studying cultivated landscapes, and the embedded model is the one that I think is appropriate for a lot of interesting questions in ecology, but it comes with caveats, ethical caveats. And instead of ignoring those, I think we should dive into those and explore them and have a dialogue about how to move that forward. And it can't be done in one talk or one session or one meeting. That would be a longer process. And so with that, I want to point out that next year's meeting will be in Salt Lake City. And a lot of the work I've shown you that I've done in ecological planning is located in Salt Lake City, so they probably would be a field trip to some of these sites if you'd like to come see them. And maybe we could do some more work in this area if people are interested. Hold a session, invite some philosophers of ecology to talk about this with us if that's something people are interested in. So please let me know. The topic of that meeting is harnessing the ecological data revolution. So it's methodological. It's asking, how should we do ecology going forward, given all these changes in technology and in practice? With that, a huge number of people have talked to me about these issues over the last few years. I can't fit them all on these slides. I tried to fit as many as I could. And I want to acknowledge a whole number of collaborators and students and friends and colleagues who have had very engaging discussions about this, and I hope that will continue. So please talk to me over the next week, and thank you very much for listening.
Hey, so it occurs to me that it's not lawn per se that's cooling Salt Lake City or evaporating a lot in LA, it's irrigated lawns. And so I think in terms of thinking about how cities can work and the ecosystem services they can provide, we got to get away from this dichotomy of lawns or no lawns. But there's a middle ground of non-irrigated lawns. What do you think about that?
Evan, are you going to enforce the introduction rule?
Brett Jackson, hydrologist, University of Georgia.
Oh, hi. Thanks for your question. So yes, lawns and no lawns. Well, it's tricky in a place like the western United States where the lawns and most cultivars can't persist without irrigation and without supplemental resources. So resource use and the persistence of cultivars are intimately tied together in a way that we could study further. Honestly, we probably could do a better job of trying to understand the options for what could persist in a non-irrigated landscape if people are open to thinking about cultivars, because right now the options that most people are given are lawns versus native plants, and that's maybe not a broad enough range of options.
All right, so that you don't get scolded, this is Paige Warren at UMass Amherst, and that was a really fascinating talk. Thanks, Diane. I was trying to reflect on the ethics part. It was really fascinating, and trying to think about the relationship between those ethical models and the concept of the honest broker, which I was curious to hear your thoughts on that.
Yeah, that's a great question. So I started out trying to use the honest broker model, which is the title of a book by Roger Pilkey Jr. Very, very insightful book on how scientists can interact with policymakers, and it gives a whole suite of options for that interaction. And I think the difference is that all of the options in an honest broker framework involve scientists handing over information to decision makers, but not being the decision maker. And if I'm sitting around the table in a design project, I'm actually saying, I think we should plant this. And I am not turning that over to an expert, because everyone at the table has an equal say. Everyone is a designer, Stuart Pickett has put it that way. And if that's the case, then I don't know if the honest broker model applies. I suspect it does not. And that's why I turned to these alternative frameworks, a physician model where we're actually practitioners. I think that might be a better analogy, but I'm not sure, so I welcome more discussion about that.
Tom Fischer, University of Maryland, Biochemistry. For the last 6 years, my lab group and I have been working with farmers and basically looking at nitrogen and phosphorus sources that drain into our local part of Chesapeake Bay. And from that work, we worked very closely with the agricultural community, became embedded within the agricultural community as trusted friends, and they allowed us to sample on their farms, their groundwater, and their ditches. And in the process of doing that, we found that certainly the largest source of nitrogen and phosphorus is, in fact, the agricultural community. It's the major land use in the area, so it's not surprising. But after all this time of becoming a part of that community, we're now find ourselves in the position of having to recommend that in order to reduce nitrogen and phosphorus inputs into our local part of Chesapeake Bay, we're likely to hurt the agricultural community. And so it's that conflict that you described earlier. So I guess what I'm looking for is your thoughts on how do we move forward at this point, working with the agriculture community to reduce their impact on the local environment and on the aquatic environment.
Well, I mean, it's very helpful if there is at some point, hopefully early in the discussion, some kind of discussion of shared values so that, if farmers want to reduce their impact, if that's a shared value among participants, then providing a suite of options, not just one, but perhaps a range of options that would achieve that scenario, maybe that would be well taken. But sometimes the values of all the different members don't align in that way. That's a more difficult conversation. I would turn that over to people in the room. There are social scientists here who have more expertise than I do in that kind of conflict resolution. Yeah.
Thank you.
Hi, Carly Zeter, urban ecologist at Concordia University in Montreal, and thanks for a really fascinating talk. I think in order to kind of move forward with a lot of these ideas you're putting forth, it requires ecologists to actually, sit down and have conversations with philosophers and physicians and people in other disciplines, which is not necessarily facilitated by the ways our departments and our funding agencies and structures are set up. And so what would you suggest to perhaps a young ecologist like myself starting out my career in forging these interdisciplinary relationships?
Well, I think we should leverage the annual meeting. I mean, we can have some really great dialogues here in a smaller venue than this. Room is enormous, you all. Wow. So we could do a more directed, set of symposia or workshops. And in the past, we've brought some really diverse people to the meeting. Last year, we did a session with landscape architects and architects, like building architects. And it was one of the most interesting discussions I'd ever had here at the annual meeting. So we should utilize that. And then beyond that, we should have a more detailed conversation about there are career issues to navigate in taking on something that has this kind of disciplinary breadth early in your career. I have done it, and I'm still here. So we could have a conversation about the level of risk and some ways to mitigate that risk, because I hope we can find a path to do that. Yeah.
Hi, Diane. It's Scott Seleska from the University of Arizona in ecology and evolutionary biology there. I study ecosystem ecology. Thank you so much for I'm thinking about the last part of your presentation about ethics, for so seriously and deeply engaging with that question. And I'm struck by what might be a parallel with the challenge that Katie Suding talked about in her earlier plenary about grappling with the inherent inevitability of change in ecology and in ecosystems and not being afraid of it. And I'm thinking, I took a photo of your 4 principles, and the fourth one says, and you could read this as also applying to Katie's question too. Ecologists, you wrote, ecologists must respect and comprehend moral ambiguity or ecological change, yet not abandon the search for what is right and good in each decision, or not abandon the search for something to hold on to in terms of ecological integrity, even in the context of change. It seems like we have difficulty as a professional society in talking about both of those things. I'm just wondering, do you think that there might be some applicability of the ethics to that ecological change question, and what do you think about it?
Yeah, I was really struck by that. I did not come here this morning expecting Katie to also cite some of the same work. I'd have a lot of these parallel issues, and that's a linkage that I haven't really made yet, which is taking all these issues we're grappling with in cultivated systems and saying, are we looking at exactly the same issues in people who are trying to restore and manage more natural systems? They may be the same, and I think that it is very difficult for our society to grapple with some of these issues. Moral ambiguity, the notion that maybe we have imperative to do good in communities. These are things that will require extensive discussion. So it doesn't answer your question at all. I just want to keep talking more about it with you.
Come to Utah, to Salt Lake City.
Come to Salt Lake. Oh, thank you, Scott. Come to Salt Lake City in 2020.
Well, let's keep talking a little bit. And I'm Wei Xun Zhu from SUNY Binghamton. Hello, Diane. Long time no see.
Yep.
Thanks for the wonderful talk and really inspirational, and as well as invitation to Utah and Salt Lake City. Continue this conversation. So my question is, you present several models. So what about the sustainability model or framework? And we even may use the tough grass as an example. If we apply the tough grass management or choice, and how put that into the sustainable framework, and what do we think about the pro and the con? Why should we do that?
Yeah, there's a huge parallel here. I didn't want this to be too long, but one could also analyze the complex adaptive systems model used in sustainability science. It's extremely applicable here, and it also it attempts to explain how the system is changed when scientists and stakeholders work together from the systems perspective. I think that is a very, very relevant model here as well. I actually think that it could be somewhat similar to actor network theory in a way. And I'd like to explore that further, but there are some disciplinary boundaries where there are certain social scientists and philosophers that approach these issues from an ANT, an actor network theory perspective, and then in the sustainability science literature and the socio-ecological literature, we've launched a set of almost completely parallel conceptual models, and if we all came together, we might find a lot of similarities and overlaps there.